we are going to be graphing quadratic functions that are given to you in Vertex form. But first we will review a skill that we're going to need in order to find the zeros. So let me review with you, or show you, if you haven't learned this, how to solve these equations. There are two ways to solve this same equation. The first way I'm going to solve it is the familiar way, and that's factoring. So we know whenever we have an x squared, to solve an equation, maybe we can factor. And in order to do that, that's minus 9. We're going to get everything to the same side of the equation and make your equation equal to 0. So now I'm going to look at this and I'm going to say, okay, I have to factor. Well, there's nothing common. The next thing I do is count my terms. There are only 2 terms. The only way to factor would be to use difference of squares, and that's x in the beginning of each. And difference of squares works if this is a minus, and it is, there's the difference part, of 2 perfect squares. X squared, and 9 is a perfect square, and that's 3 times 3. Plus and minus in each of these. So now when you continue to solve, x is equal to negative 3, and x is equal to positive 3. These are your 2 solutions for x. And we know with an x squared, we usually expect 2 solutions. If we don't, there's going to be a reason why, if we don't get 2 solutions. Over here, a second way that we can solve this equation is by taking the square root of both sides. And we can kind of even do this in our head, and we could think of what number squared gives us 9, and a lot of us are going to say 3. And here's your square root, the square and the square root cancel, equals square root of 9 is 3. But here's the story. On the left, this equation had 2 answers, and on the right, the same equation, we got only 1 answer. Okay, the square root of 9, yes, it is 3. But when you're solving an equation, a quadratic equation, by taking the square root of both sides, it is on us to remember that the answer is positive and negative 3. If you take negative 3 and plug it in, negative 3 squared, it's negative 3 times negative 3, yeah, that's positive 9 also. So that works. So remember, whenever we solve a quadratic equation, and this is, of course, if there's no middle term, see how we're missing that middle term of just plain old x? We can say something squared is equal to the number, take the square root of both sides, but this is the big thing. It's on us to remember the plus and the minus. Okay, let's move on. For these quadratic equations, we're going to find and plot the zeros, vertex, y-intercept, and another point. We're also going to graph the axis of symmetry. It's going to help us out a little bit. This equation is given to us in vertex form. Now, each of the forms that we talked about last week have something very useful from the start. And what's very useful in vertex form is the vertex. So we can pull the vertex right out of this equation. And remember, when we think of vertex, we think opposite, same. Opposite of the number with x is your x-coordinate. Same number that is outside the parentheses is your y-coordinate. So our vertex here is going to be opposite, same. Over 1, down 2, 3, 4. There's your vertex. Remember, your vertex lives on the axis of symmetry. So I know this right here is my axis of symmetry. So however my parabola goes, it is symmetric about this line. So I'm going to start writing in some of my stuff on the bottom, because so far I have 2 things. I have my vertex, you'll remember we just plotted 1, negative 4, and this is my x equals 1, right? That's your axis of symmetry. The next 2 things they need are the zeros and the y-intercept. Okay. Well, it used to be, in the examples that we did previously, that this number here on the outside all by itself was the y-intercept that only works when the equation is in standard form. This equation is not in standard form, it's in vertex form. And it would not make any sense if negative 4 here was also the y-intercept because it goes straight over, right? So we know this is our point, our bottom point, and it's going to have to curve up. So at this point, let's remember, I'm going to do it this way, a couple of things. We're going to find our zeros, and we're going to find our y-intercept. Remember your zeros, and we just kind of found a couple of them. Your zeros have a number for x and 0 for y, and the y-intercept has a number for y and 0 for x, and this is going to help me as I find my numbers, because I'm going to remember that here the y has to be equal to 0. So I'm going to come back up to my equation, and I'm going to copy it over and plug in 0 for y. So it will be 0 equals x minus 1 squared minus 4. Okay, so now, what I just did a moment ago, with the taking the square root of both sides, that's what skill I'm going to use here. It looks like here I have one term that is squared and a second term that does not have a variable. So what I'm going to do is get one of these on each side of the equal sign. This guy is positive, leave him, add 4 to the other side. It would probably look better to most of us if we flipped this, so I'm going to do that. And now what I'm going to do is say, okay, so here I have my variable, or something squared, is equal to 4. Happens to be a perfect square, so this will work out nicely. Take the square root of both sides. The square and the radical cancel, so there's my x minus 1 that I'm going to take out. Recopy that guy. And on this side, I take the square root of 4, and it's 2. And the big thing I have to remember that when I solve equations, quadratic equations, by taking the square root of both sides, it is on us to remember the plus and the minus. Okay, so now I want to continue solving for x. Add 1, and x is equal, this is where it gets a little weird, right? So I'm going to write 1 plus and minus 2. This gives me 2 solutions. Remember, we usually get 2 x's. Here's how we're going to get them. X plus 2, or sorry, 1 plus 2, and that's 3. So one of your x's is 3, and x, I keep saying that, 1 minus 2, and that's negative 1. So your other x value is negative 1. These x's are your zeros, those are your x-intercepts. One's at 3, one's at negative 1. Let's go back to our graph. One is here at 3. The other is at negative 1, and I do see my axis of symmetry, and they look equally balanced about that axis of symmetry. Right? They are symmetric, so I'm liking my answers so far. I have negative 1, 0, and 3. 0, because that's what my zeros look like, number, comma, 0. Next up is this y-intercept. This is how I'm going to find it. So now in the y-intercept, the x-coordinate is equal to 0. So I'm plugging 0 for x. So that's going to be y equals, for x, right? So we're going to plug in 0. 0 minus 1 squared minus 4. Well, 0 minus 1, that's negative 1. Negative 1 squared, well, it's positive 1. Minus 4 is negative 3. So y is negative 3. That is my y-intercept. Over here, down to 3. And I can write in that point 0, negative 3. Okay, so now I can start graphing my line. This side looks pretty good, right? That's what that's going to look like. Arrow going up. And then my other side, well, just so I get my other point of symmetry, These are balanced. I'm going to flip this one over the axis of symmetry. Here it is at -3. I'm going to come over here and I'm going to put it at +2, -3. That's just going to be my other point, and I'm going to graph over there. And that is my parabola. 2, -3 would be my other point. So I see my parabola and it looks pretty good. Okay, so now we are going to, on our own, do some more practice. Try these guys. Okay, so this is going to be 1 and 2. 3 and 4 have a little bit of a hitch to them, so I'm going to at least begin one of them with you. I think I'll start number 3. First thing I'm going to do is pull out my vertex. Remember, your vertex is opposite same. 3, -2, so I'm going to go over 2, 3, down 2, plot your point. That also gives me my axis of symmetry. Draw that in, even if when you draw it, it's light, who cares? That is x is equal to 3. So down here, we're going to write in both your axis of symmetry and your vertex. Next, you have to find your zeros and your y-intercept. Okay, remember for your zeros are going to look like this. It's going to have an x number and then 0 for y. Y is equal to 0. So I'm going to rewrite my equation, and I'm going to plug 0 in for y. Add 2. I'm going to flip it so it looks good. Solve by taking the square root of both sides. This square and the square root are going to cancel each other out. X minus 3 is equal to, well, I can't take the square root of 2, and that's okay. Plus and minus the square root of 2. Add 3, and I'm just going to put that plus 3 in front, and x is equal to 3. I don't need the plus anymore because that just means it's positive. Plus and minus radical 2. And this kind of looks like a solution you would get if you used the quadratic formula, which is how you would have to solve this if you were given this equation in standard form. Okay, remember this does give you 2 answers. One of your answers is the 3 plus radical 2. And your other answer is 0. Sorry. And your other intercept is 3 minus radical 2. Okay. I get that that looks weird to us. Let's see what that's going to look like if I go ahead and graph it. Okay, so here we have this. So now I want to know what 3 plus radical 2 looks like. Whoops, I messed something up. 3 plus square root of 2. 4.4. So this guy here is 4.4. Let's find that up here on my graph. Well, there's 4.4 is kind of in the middle there, so that's one of my zeros. And then I'm going to come down here, and I'm going to do 3 minus the square root of 2. And that's going to the square root of 2. That's better. 1.6, if you will. 1.6. So then I come back up here in between 1 and 2. That's about 1.6. And see how they're kind of symmetric about my axis of symmetry? And my graph is going to start going this way. At this point, I would continue if I were you, and I'd find the y-intercept in the other point. I am just going to pause the video here and let you do that work on your own.